Hello, and welcome to the second episode of Fab Live. Now, for this episode, we'll talk about how to use the laser cutting and engraving machine. Now, for this episode, I'll be dividing it into three parts. First part, we'll talk about the designing process. Second part would be the preparation for the fabrication. And the third would be the fabrication, which is like the easiest part, would be the simplest part of the video. So for the design process, we can't really talk about the design process without really talking about the basics of digital fabrication. Now in digital fabrication, you do need to understand that it's not like magic. So ultimately, in digital fabrication, you're just talking to the machines. And the most common question that I actually get from beginners is the question, what app did I use to be able to, create designs and create models for digital fabrication? And with that, whenever I give them something that they're not familiar with, they say, "Oh, okay, so can I use this application instead?" And for me, ultimately, it doesn't really matter which app you're going to use, because what matters really is just the file. So personally, I use three applications whenever I make designs for digital fabrication, and that depends on the nature of the task. So I primarily use Adobe Illustrator, Adobe Photoshop, and SketchUp, and with those three applications I could operate almost all of the machines, if not all of the machines in the lab, from 3D printing, laser cutting and engraving, CNC milling, and even digital embroidery. But besides those apps, I could also use Fusion 360, AutoCAD, and Blender. But I prefer the first three apps that I mentioned because I'm much more comfortable with those apps, and well, I just work faster with them. So in laser cutting and engraving, we go back to the question of what file do I need to have in order to operate the laser cutting and engraving machine. Now, for that, we need two different files, one for cutting and one for engraving. For the cutting, you'll need a DXF file, so that's a vector file, we'll discuss it later. And for the engraving, you'll need a bitmap, a black and white bitmap file for the engraving, which we'll again discuss later in this video. So vector files are actually 2D images, but works differently from your typical pixel-based image files, which are commonly used for your typical photos and images. File formats like JPEG and PNG, they're all actually pixel-based. Now, what's different with the vector file is that vector files are, besides the color, they're actually composed of lines drawn in your canvas, and those lines are actually the lines that the machine will be following all throughout the fabrication process in fabrication. So with that, it's not enough to just bring a high resolution photo if you want to have something cut. So for laser engraving, you need a black and white bitmap file. Now, bitmap file is a pixel-based image, which, even though I discussed earlier that it's not enough to bring a high resolution photo if you want to cut using lasers, but engraving is a different process. So what we have here is our user interface for Adobe Illustrator, and as you can see, you have a lot of tools and buttons in the UI, but there's no need to be intimidated. We won't be using all of them, and you'll actually use just a few of them in designing. So to start, if you want to draw, you could use this. We'll start with the rectangle tool to draw a rectangle. And if you're looking for other shapes, you could
long press your left click with your mouse 1, and you'll be taken to more options for drawing. But yeah, let's stick for rectangle for now. Then this would be your select tool. So if you want to select an object, you use the select tool. And then if you zoom in, you actually see a line that's highlighted whenever you hover your mouse to the rectangle. Now that's how you know that you have a vector, because it highlights your the shape of your drawing. Now to put something in contrast, I already imported a file photo, and as you can see, if we hover the photo, what you get instead is this box instead of the actual shape. So as you can see, the photo seems to go under the rectangle. If you want to take that the front, on the right side you'll have your layers. So the layers actually just function as well layers. So the ones that are on top will show up on the top most of the drawing of your artboard, and then the bottom is, well, yeah, it's in the bottom. So if you want to take this photo forward, you'll just have to drag. You can just drag, and then there you have your photo, and then we can resize this, and then there. So as you can see, there's automatic snapping, which is useful when you're designing. So yeah, that's the basics of Illustrator. If you're looking for, let's say you want to create custom shapes, you can use the pen tool. So the pen tool, yes. So with the pen tool, you could create custom shapes like these. Now you do take note what happened while we were drawing is that something like this. So the material is covered by some awkward shape, but you do know that it's coming from the shape that you're drawing. Now why that is the case, and what if you're trying to draw a complex shape and then the fill is getting in the way, is that you could just click this, make sure that it's highlighted, and then you click no fill, so that you'll only see the stroke. But you also have to be careful, because you can also set the stroke color into none. So when that happens, you actually don't see anything. But if you hover, there, you still see the shape. So it's still a vector file. The machine would still read this vector file, but something that you just have to be careful with. And whenever this happens, you could always check the layers. So everything that you just draw, if we click it here, actually gets highlighted. So all of these are vectors whenever you're drawing. Now if you want to go with curved lines, you could use your pen tool, and then you click a starting point, and then whenever you want to draw a curve, you could just long press and drag, and by then you now make your curves. Now you could combine these curves with straight lines to be able to create whatever shapes that you want to shape. Now we could trace this, but yeah, so that's where the work goes in designing vector files, because if you want to cut something that's this complicated, that means that you're going to have to trace everything. But yeah, that's why it's not easy, but it's fun. So what we would want to try to do is we just want to make something that can that involves cutting and involves some minor engraving for our work, and also some text. So if we look at the left side, that's where your tools come in. So this is your select tool, and this is your direct selection tool. So the direct selection tool is designed to actually select specific parts of your shape. So if you want to edit your shape, you can just use your direct selection tool, and then let's say we want to edit this corner, so you just have to double click and then drag. So as you can see, even if you finished your shape, you can still edit them. And what this circle does is it actually curves and fillets your shape, which is a cool trick. So again, depends on what you actually want to achieve. You could actually do it with spend a little direct selection tool. Next that would be useful would be this type tool. So the type tool is pretty straightforward. So you just click and then you type whatever text that you want to type. Now if you want to change the text, you could go to the character here. Well, the character option is what's about the font and the characters of your text. So you could change the fonts of your text. So there. Then you could also change the effects, things that are better explored rather than discussed. You know, it's designing is fun. Anyway, besides this, what else? Yeah, I think those are the basics. And for this activity, I already prepared my own version of this. So it's this. So as you can see, I already made my own design, and if we hover it, yeah, it's actually a shape. There. Now, getting proficient with these tools takes time, but practice makes perfect. And the only thing to get better at doing this is actually by practicing. So I may be able to teach you the basics, but getting proficient with these tools, that's all up to you. If you want to explore more, there are many tutorials in the internet. For this, there are many tricks for digital fabrication that might be useful to you, depending on the nature of your work. So with that, we'll check everything. So what we want to do from here is that we want to cut this, we want to cut these. I mean, we start with cutting this out, and then engraving this, and then cutting this. Okay, so technically, I mean, generally it involves 3 different processes, 2 cuttings and 1 engraving. So, which means we'll be needing 2 different files, a bitmap and a DXF, the vector file. Now, to render that, to render your vector file is you need this. Okay, this is another trick. Whenever you export your bitmap file, it will export the entire artboard. So if you want to constrict your image, or if you want to make sure that the image is centered, you're going to need to make sure that your artboard is the exact dimensions, the exact square as your entire image. It'll be handy once we proceed to the second part of this video. It'll make sense. So what I would do in this case is that I would select this artboard tool and then just drag this here, so that whenever we export our bitmap, it will more or less be on the same shape as our DXF, and that would be useful on the second part of the process in laser cutting and engraving. Because if we select images, as you can see, you have this square bounding box with a you can't really see the center of the box, since there, that's the center of the box. So there's an image there, and we'll be using that center as reference to center everything, to match everything, so that your fabrication won't be skewed. So if we start with, we'll first start with exporting our bitmap. So since we won't be needing this and this, what we want to do is just export text. So if we export this, we'll be exporting a white image, and then this black pixels for the text. So to do that, we need to go to File, Export, then bitmap. So let's name that text. Export. And then we'll make sure that's on 300 pixels per inch. As of Y, you need the most resolution if you want to make really good quality engravings. So yeah, that's useful. And then as of this, just have to click OK. And then if you check, there, that's our, this is our text file. Now, the next thing that we need to do is to export the vectors. Now, what you will be doing is, if you export the vector files, it doesn't really matter if you have your image files exposed, since the DXF file won't exactly identify them, but we'll just hide that for the meantime. I mean, while we're exporting it. So we export, and then DXF, there, export. Everything is I already designed this. I already set this as actual measurements, so we'll leave that as is. So these are actually in inches, so it's 3 by 5 inches for the dimension. So yeah, that's how we do it.
So I transferred to the other machine, and this is for the second part of the video. It's all about preparing for fabrication. So we're using RDworks. It's the software that we use to prep our designs for laser cutting and engraving. So this is the UI. Again, no need to be intimidated, although you can technically draw while using this app, but I do not recommend drawing in this app. Maybe some minor changes, but not your main drawing application. Importing files is way easier in this app rather than drawing directly from this. So if we want to make something and we want to prep something, so initially this means that we already have our designs exported in different formats. So what we would be doing is we'll go to the import button, then we'll start importing files. So desktop. So as you can see, we have our outputs exported, and then for this application we could only export one, so we'll import one at a time. So here's where the center works conveniently. So if this, oh, it's in mm. So if we want to convert this into inches, that was an error on my part. If you want to convert this to inches and get what we need to do is just to set the actual measurements. But since we exported everything, we exported it on actual size, and the bounding box are basically the same. We could just input the dimensions from this bitmap image into this, since they're basically the same size. So with this, we'll have our y, our height. We'll just copy that, and then with this, make sure to lock the dimensions and then paste. There. Now, as you can see, there is a portion, there is this darkened portion in the in this object. Now, the reason for that is because we had our background colored, so which means part of the export process was actually exporting the pixels, and it treats the pixels from the shape, so it fills your vector with something. So what you want to do with that is simply wait, it's not scan, this is cut. So we're technically changing the parameters from scan to cut. So when we say scan, it scans the entire thing, and then when we say cut, it just follows the profile of the shape. So we set that to cut, that's okay, and now we have our shape. So the export technique we used earlier, why we intentionally put everything in the same size, because if you try to select this, you'll have your center as your reference point. Same thing with this. So what we would be doing is we'll be using that center as reference whenever to align everything. So how we do that is you simply select this and then look at the X and Y position. So this is the X and Y position and this is your dimensions for your work area. So what we want to do is simply copy and paste the dimensions. Oops, nope, not this. No. There. So they are aligned horizontally, and then you just copy and paste it again. Open this here. Okay, so that everything is aligned. There's no need to worry about the excess, because those are just the bounding box. Those are still in pixels, so that won't matter that much. Next is we need to set the order of the work. So we first set scan here as first, so it follows this. It still has that layering concept as the order of work. So what happens here is first it scans your the image, and then next would be the cut. If you want to know which shape is that, you could just right click and it highlights. So as you can see, this cut highlights the outer part, the actual profile of the entire workpiece, which we will be cutting last, because in laser cutting engraving you need to work from the inside out, because if you work from the outside in, the laser might cut off your outer your profile. So what would happen then is your workpiece might move, and it might offset the alignment of your work. So what we need to do is we need to cut from the inside and then slowly work outside. So from here, if you want to right click, if you want to confirm, you can just right click this, and as you can see, this would cut this first. So first the machine would scan, next the machine would cut this part, and then lastly this part. Now the next thing that we need to do is we need to set the parameters of the lasers. Now, so the principle is rather simple. You'll be playing with two factors. First is the laser output. It's the power output of the laser, and then next would be your work speed. Now your laser output would determine how fast the laser would cut through your material, and your workpiece would determine how slow the work would be. Now, one thing that you need to consider is that even though your output is rather high, if you don't give the laser enough time to work the workpiece, now, one thing to consider, even if your laser output is rather high, is that if you don't give enough time for the laser to actually cut through your material, it won't cut the material and just rather leave a mark, which is something that you could use if you want to put some style in your fabrication. Now the same thing with scanning. For scanning, the principle is you set it with say mid to high power, and then you work really fast so that your material won't be burned, while at the same time leaving a significant depth. for the engraving. And for the cutting, the general idea is that you move rather slow, and your laser output would be high. Now for the parameters, what I usually use for scan is 50-50-300. As of where did I get those numbers? Those are from my personal experience. So these parameters actually work generally for most jobs on wood. So yeah, we'll have 50 for our minimum power, 50 for our max, and for our speed, we'll set that to 300 mm per second. Now, since these two jobs are basically the same, they're just cutting, so we'll set that to the standard, which is 99-10. So we'll just confirm everything that this would be 90, this is 90, then this would be 10. So once we're done, we'll save this just to make sure. So let's see, this is layout, save, and then we'll use this as just backup whenever we're fabricating. So we're in the last part of the video, which is the actual fabrication. So yeah, I transferred to another unit for the actual fabrication. What we did, since we saved our file, is just we'll download the file to the laser cutting engraving machine with that download button, and then we'll start the fabrication. Okay, so once we've downloaded our file, it's already downloaded. Okay, so once we downloaded our file, this is the actual UI of the machine. Once we downloaded our file, we could just set the origin, and then, so which means this point would become the origin. Then we'll just press frame, so we'll be able to know how big the actual workpiece would be. So we'll move it a bit here so that we'll be actually able to save space. Then once you're all good, we'll need to go to step 2, which is calibrating the z-axis. Okay, since we're dealing with lenses, lasers actually have their focal points. So what you would be doing is that you need to find that focal point where the laser is the most powerful, so that cutting through your material would be efficient. So what I usually do is that I just get these two and stack them together, and then adjust the z-axis. So conveniently, we have a z-axis function to our machine, so you can actually adjust there. Now once that, so as you can see, it's just barely sits on top of these two stack 1/4 plywood. After that, we set it to origin,
set the frame, and then we start fabricating.
So here's our final output. So thank you for watching, guys, and stay tuned for future episodes with me in Fab Live, where I'll teach you how to create 2D assemblies. So I'm hoping to use the CNC milling machine for that episode. So yeah.